Hi, today we will learn how do you find the vector equation of a line and how can you calculate the distance between a line and a point. For that purpose, we have chosen a question from P3 of A-levels and it is from question 9 of May-June 2022 paper. So let us proceed at what is the statement of the question. So they have given us a cuboid, and in that cuboid, they are saying that OA is 2 units, OC is 4 units, and OG equals to 2 units. They have told us that M is the midpoint of the diagonal DF. And similarly, they have told us that N is dividing line segment AB in such a way that AN equals to thrice of NB. So what are the requirements of the question? In this question, we need to calculate the position vectors OM and MN in terms of IJ and K. And similarly, we need to calculate the vector equation of a line through M and N. And similarly, in the third part of this question, we need to calculate the perpendicular distance of a point O from a line through M and M. And we have to prove basically that the distance is root of 53 upon 6. So it is a bit difficult question of the paper. So let us analyze this cuboid. So you can see that the length, width, and height is uh, taken as the x-axis, the y-axis, and the j-axis, and the k-axis respectively. So we are given that OA equals to 2i. So we can write a column vector as 2, 0, 0. Similarly, OC was given as 4 units. And since it is along the j-axis, so we can write it in column vector form 0, 4, 0. Similarly, the vertical axis is along the k vector. And since OG was given as 2 units, so we can write a column vector as 0, 0, and 2. So how can we basically proceed in this question? So we are to calculate two position vectors. One is the position vector OM and the other is basically position vector MN. So in the solution, first of all, we will apply the position vector rule. And since AC is equals to the position vector DF, so for position vector DF, we will write position vector OC minus position vector OA. And since both OC and OA are given in the question statement, so we can easily compute this as -2, 4, and 0. Now, after calculating this DF, we will calculate the position vector DM. And since DM is halfway from D to F. So we can write it like dm is equals to 1 upon 2 times df. And since we computed df as -240, so dm will be -120. Now we will apply extension of triangle law. So we can write position vector OM is equals to position vector OA plus position vector AD and plus position vector DM. So position vector O is given as 0, 2, 0, 0. And position for position vector AD, we can realize that OG and AD are basically equal. Why? Because it is a cuboid. So in place of AD, we can write OG, which is already given as 0, 0, 2. So plus DM, we already calculated DM, and hence we will add the 3 column vectors and we can easily find OM as 1, 2, 2. So that was the first requirement to calculate OM. And now to calculate MN, how we will proceed? For that thing, they have given us an identity, a ratio that position vector AN is equals to 3 times position vector NB. So we can write it like position vector AN ratio position vector NB is 3 ratio 1. Now, what is position vector AB? It is basically equals to position vector OC, and hence it is 0, 4, 0. Now, position vector AN can be written as 3 upon 4 times position vector AB. So it is 3 upon 4 times 0, 4, 0, and hence it is 0, 3, 0. Now for position vector ON, we can apply the triangle law. ON equals to OA plus AN. So OA is already given, it is 200, and AN we calculated as 030. So adding the two position vectors, we get ON equals to 230. Finally, to calculate MN, we will apply the position vector rule. So position vector MN is equals to position vector ON minus position vector OM. Position vector ON is 230 and position vector OM is 122. So hence we can easily compute position vector MN. So that was the first part of this question. Now in the second part, we need to calculate the vector equation of a line through M and N. Now we already know that a vector equation can be represented by a generic equation, position vector R equals to position vector A plus T times position vector P. In this equation, A is basically a given point, T is the parameter, and P is direction vector of the line. Now, for the given point, we can take the point M, and for the direction vector, since it is a line through M and N, we can take position vector Mn as the direction vector of this line. So in place of OM, we will put the column vector of OM, and in place of Mn, we will put the column vector of Mn, and hence we get the vector equation of the line through M and N. Finally, in the third part, we need to calculate the distance of a point O with a line from M to N. Now, for that thing, just consider this diagram in which I have made the line M through N. And you can see that a perpendicular is drawn from the position vector O to the line Mn, and the foot of the perpendicular is represented by F. Now we are to calculate basically the distance OF. How can we proceed for this question? So first of all, we will find a unit vector in the direction of the line Mn. For that thing, we will calculate unit vector of the direction vector Mn, since the direction vector of the line is basically the direction vector of Mn. So we will calculate a unit vector in the direction of Mn by dividing position vector Mn with its magnitude, and hence you can see we got a position vector equals to 1 upon root 6, 1, 1 minus 2, which is basically a unit vector. Now, in the second step, we will take the dot product of the unit vector u and the position vector mo. So unit vector u we already calculated, and unit vector mo is basically -1, -2, and -2. So you can see for the dot product, we multiply the x component with the x component, then we multiply the y component with the y component, and then we multiply the z component with the z component, and hence we add all three products to get the dot product. So we got the dot product as 1 upon root 6. So this dot product is the length mf. Now we will calculate the length of the hypotenuse by calculating the magnitude of the vector mo. So you can see that the magnitude of unit vector MO is 3. Finally, we will apply the Pythagoras theorem to calculate the length OF, and therefore the length OF is equals to root of 3 squared minus 1 upon root 6 squared, which can be simplified as root of 9 minus 1 upon 6, which can be simplified as root of 54 minus 1 upon 6, which is equals to root of 53 upon 6. So hence you can see that we easily prove that the distance between the line Mn and the position vector O is root of 53 upon 6. Thank you.